Welcome to Understand the Math. In this problem, we're going to find the least squares line that best fits the following data points. This is just finding the least squares line of best fit. The equation of that line is going to be y is equal to beta 0 plus beta 1 times x. There is no line that's going to pass through all those data points. So this line that I've just written down, that's called our line of best fit, and it comes as close as possible to passing through all the data points. We're going to let a vector x hat contain our parameters beta 0 and beta 1, and then define x hat, which will give us beta 0 and beta 1. We have what's called normal equations. For x hat. And those equations look like this. It's A transposed times A times x hat is equal to A transposed times B. Our matrix A contains two columns, and that's because we have two parameters. So let's make a note up here that the number of columns of matrix A is our number of parameters. That's our beta 0 and our beta 1. And then the number of rows of A is just our number of data points. Now we can go ahead and fill in matrix A. The first column is going to contain just ones, because we have a 1 multiplying beta 0, and then the next column is going to contain our x that multiplies our beta 1, so that's going to be our x coordinates, 0, 1, 2, and 3. And then our vector b on the right-hand side comes from our y, and that's going to contain our y coordinates, and that's going to be 4, 4, 5, and 5. So now we're all set. What we have to do now is we have to create these normal equations. So we're going to start by taking A transpose. So the first row of A becomes the first column of A transpose. So that's 1, 0. Then we have 1, 1, 1, 2, and 1, 3. So that's our A transpose. We multiply that by matrix A. And then we have our x hat, which I'm going to just go ahead and put in as our beta 0, beta 1. On our right-hand side, we're going to have A transpose again. So that's 1, 1, 1, 1, 0, 1, 2, 3. And we're going to multiply that by our vector B, which is 4, 4, 5, 5. Let's go ahead and let's do this multiplication. We're going to start out by multiplying this row by that column, and that's going to give us a 4. Then we're going to multiply by this column, and that's going to give us a 1 plus 2 plus 3, which is a 6. We're then going to multiply this row by our first column, and that's going to give us another 1 plus 2 plus 3, which is 6. And then we're going to multiply the green row times the pink column, and that's going to give us, we better write this down, 1 plus 4 plus 9, which is 14. And that multiplies our beta 0, beta 1. And then on the right-hand side, we're going to have this row times this column, and we're going to pick up, let's see, 4 plus 4 is 8, and then a 10, so we're going to get an 18. And then down below, let's write this down. We're going to get a 4 plus 10 plus 15, which is going to give us a 29. Now we can go ahead and solve this linear system of equations. There's a couple ways we can do this. We can use row reduction, or we can multiply by a matrix inverse. I think I'm going to choose to do the matrix inverse. So I'm going to say beta 0, beta 1 is equal to 4, 6, 6, 14 inverse times our right-hand side, 18 and 29. Our beta 0, beta 1 is going to be equal to this. So to take the inverse, we're going to take 1 divided by the determinant. So the determinant is the main diagonal multiplied minus the off diagonal. So that's going to give us a 56 minus a 36. And then inside the matrix, the main diagonal elements in blue switch places, and the off diagonals get a negative. And then we have our 1829. This is equal to 1 over 20. Now we're going to go ahead and multiply. 14 times 18 is 252, and we're going to subtract off 29 times 6, which is 174. Then we have a 6 times an 18, which gives us a minus 108. And then we're going to add 4 times 29, which is 116. And this gives us 1 over 20. And our top entry is going to be a 78. And then our bottom entry is just going to be an 8. So our final answer is going to be a 39 over 10 up top and a 4 divided by 10 in our second component. Now our last step is to write our line of best fit. So our line of best fit was y is equal to beta 0 plus beta 1 times x, and we just found what those values are. We can write our final answer as y is equal to beta 0. That's beta 0, and I'm going to write that as a 3.9 plus beta 1, which is this, and I'm going to write that as a 0.4 times x. So that is what we call our line of best fit, and that's the line that comes the closest to passing through all 4 of those data points.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.